Hi everyone, today me and my team would like to present a topic, namely development of potato chip from food waste in food microbiology and food physics aspect. Without further ado, let's begin with the food microbiology part.
On characteristics and specifications of the product, for this assignment we will be using Mr. Potato Chips as the base of our product. These are how the chips will look like before the addition of the powder. Then, this is the orange powder we have obtained from processing waste orange peels. So, for the properties of the finalized product, to the side is how our final product looks like after we have processed it. Below are a few important properties of the product that we will discuss. It includes color, shelf life, flavor, and risk of rancidity. For the color, the potato chips have a lighter color according to the results before. Before the potato chips were added powder on top of it, its L value is 71.35, which is pretty bright. But after a powder is added, the value drops to 54.36, which means that the color is darker compared to the original chip. But for shelf life, the shelf life of potato chips can be up to 6 months according to studies. For flavor, the flavor of the potato chips are savory in taste, but with the addition of orange powder onto the chips, the potato chips will have a fusion of orange and savory flavor. Then for the risk of rancidity, potato chips have a large amount of fats in it. It has 27.5 grams of fat per 100 grams. Thus, it has a high risk of oxidative rancidity, which makes the potato chip taste rancid and become unfavorable to consume.
There are a few types of food spoilage that we might encounter, including microbial spoilage, physical spoilage, chemical spoilage, and appearance spoilage. Microbial spoilage is that the food is contaminated to the microorganism. Then the physical spoilage is the food was physically damaged during harvesting, processing, or distributing. Next, chemical spoilage is that the chemical reaction in food that changes its color and flavors. Lastly, the appearance spoilage is that there is some viable growth of microorganisms can be spotted on the surface of the food. Potato chips have a very high chances to get contaminated by bacteria and fungi. Consuming such contaminated chips may cause foodborne illness that is a great threat to our health. Bacteria are mostly free-living organisms often consisting of one biological cell. They constitute a large domain of prokaryotic microorganisms. Fungi are a group of eukaryotic organisms that includes microorganisms such as yeast and molds, as well as mushroom.
The potatoes are checked and examined for quality as they arrive at the facility. Green edges and blemish are expected on the potatoes. The potatoes are transported to the various stages of processing through a conveyor system. The potatoes are washed in cold water after they have been peeled. The potatoes are sliced into paper thin slices using a revolving presser. The slices are washed again in cold water to eliminate the starch that is released when the potatoes are cut. As the slices flow into oil-filled trough, they pass through air jets that eliminate any excess water. Salt is sprinkled from receptacles above the trough of chips as the pieces drop. Flavored potato chips are passed through a drum with a desired powder seasoning. Finally, the nitrogen filling process must be complete without allowing too much air into the bag and without damaging the chips. After the frying process of the chips, packaging is the last step before delivery is made. Nitrogen packing machine is the method of filling package with nearly 100% nitrogen. The nitrogen gas suffocates the oxygen in the bag, which is subsequently filled and sealed with the chips. Slack fill is when chip manufacturers purposely pump the packaging with nitrogen gas to safeguard it from harm during shipping. Because the chips inside the bag would break through being stacked in transit or crammed onto a grocery store shelf without the cushion of nitrogen gas, they would mostly arrive as a bag of crumbs. To eliminate the oxygen, nitrogen gas acts as a preservative agent and is continuously inserted from food packing during filling. The oxygen content can be reduced to 3% or less using this method. Chips would have a sustainably lower shelf life if this procedure is skipped. As a result, Consumers will benefit from improved shelf life and a longer expiration date. The chips are as crisp as the day they were packaged. Once the pack was opened, the unavoidable mixing of outside air with the content of a bag of potato chips tends to oxidize the contents and impair the freshness. The oxygen gas, which is now present in the bag at a concentration of 21% of oxygen, begins to break down the oils that contribute to the flavor of potato chips. Given the ambiguity and unpredictability of spring weather, it may be necessary for growers to postpone potato plantings in some circumstances, which raise the crucial issue of suitable storage conditions. If potatoes are not properly stored, their quality will deteriorate quickly, adversely affecting the crop's performance and productivity. The four main factors that growers should consider when storing potatoes are humidity, light, ventilation, and temperature.
High humidity is required to keep seed weight and tuber quality stable. When relative humidity falls below 90%, weight loss becomes significantly more pronounced, so keep it high 90 to 95% to maintain the potato's quality and firmness. If exposed to light, potatoes will turn green, and the length of time they are exposed to light affects how quickly they turn green. However, it is a sign that higher concentration of the glycoalkaloid compound solanine may be present. The green coloration is actually chlorophyll, which is generally safe. If consumed in large quantities, the compound can be toxic. Seed tubers should be kept away from light and stored in the dark to avoid solanine formation. Potatoes should be kept in a well-ventilated, cool, dark, and humid environment, as well as preventing the growth of bacterial and fungal pathogens. Air movement also helps to maintain the desired temperature and humidity levels. Additionally, it assists in preventing free moisture condensation from forming while being stored. Potatoes should be stored at a temperature between 40 to 45 Fahrenheit. A lot of sprouting degrades the quality of potatoes and is a result of warmer temperatures. Furthermore, warm storage conditions promote disease growth, creating an ideal environment for organisms that could harm crop establishment and yield. The possibility of increased water loss is increased by warm storage conditions, which also increase transpiration and respiration. On the other hand, storing potatoes at low temperatures can result in them turning greenish or black and limiting their quality and vigor.
That's all from the food microbiology aspect. Now, let's have a look at the physical property of this food product. As we know that potato chip is produced after deep frying process, we can expect that the potato chip has a relative low water activity compared to the fresh food. In our experiment, the potato chip is just taken out from vacuum package, so it is not affected by the environmental humidity. Besides, the adding of the orange peel powder didn't affect its water activity. Hence, we can conclude that the water activity of potato chip with orange powder is 0.398. The minimum water activity required for microorganisms to grow is 0.6. As for the water activity of potato chip, all mold, yeast, and bacteria are unable to grow. It's also resistant to liquid oxidation, enzymatic reactions, and Browning reaction. With the vacuum packaging and low water activity, this allows the potato chip has a longer shelf life. There are two factors affect water activity of food, which are the processing method and storage environment. As for processing method, frying and drying cooking method will decrease the water activity by physically removing water. Adding solute like sugar and salt also reduce the water activity. Storage environments such as freezing will remove the water in the form of ice, whereas storing in the room temperature with a higher relative humidity, the food will absorb the moisture from the environment to reach the equilibrium. Hence, its water activity will increase. The second food physics property of the food that we are talking about is moisture content. Moisture content is the percentage of water in the food. The moisture content of potato chips are decreased from around 18% to almost 2% after deep frying. In this experiment, moisture content is measured in wet basis, which is about 4.6%. In terms of color analysis, the results show that original potato chips look more plain compared to the others, which lightness is 71.35, redness is 0.09, and yellowness is 26.05. Although potato chip added with fine powder has a lighter color, as its lightness is 54.85, its redness and yellowness is lesser than the potato chip with coarse powder. The result is under expectation as smaller particles can reflect more light compared to larger particles. Hence, potato chip with fine powder has a brighter color. The factor that affects color of the potato chip is the orange peel powder imparted on the chip. In this experiment, two types of powder are added on the potato chip to impart the color. Fine and coarse powder show slightly different results because of different particle size that reflect light differently. Fine powder provides a lighter color compared to the coarse powder. Therefore, potato chip added with fine powder reflect more light and provide a more attractive look.
The food texture is a term of sensory experiences originated from visual, audio, mechanical, and tactile stimuli. The potato chip we chosen has a coarse and uneven surface. The surface of the potato chip became gritty after sprinkled with the coarse orange peel powder. In terms of the audio stimuli, we broke the potato chips and listened to the cracking sound produced. Our potato chip has a crispy sound which indicates it is fresh and sealed properly beforehand. However, to obtain more reliable results on texture properties of the potato chips, we need to perform texture profile analysis. Texture profile analysis, in short TPA, is a double compression test, also known as a 2-bite test, whereby potato chips are being compressed twice using a texture analyzer to provide insight into how samples behave when chewed. The texture properties measured by TPA includes hardness, fracturability, springiness, resilience, cohesiveness, adhesiveness, gumminess, and chewiness. This slide showed the texture properties of the potato chips sprinkled with fine orange peel powder under normal conditions. Hardness of potato chip for the first cycle is 683 gram, which means that the amount of force required to deform the potato chips is 683 gram. The hardness of the second cycle is 521 gram, which is less than the first cycle, indicating that the potato chip did not fully recover from the deformation as external force is applied. The adhesive force of 2 gram indicates that the fresh potato chips require 2 gram of force to separate the potato chip from the probe, which also mimic our mouth biting action. This also reflected how sticky is the potato chip when we bite. The resilience of potato chips is 0.33, while the fracturability of fresh potato chips is 116 gram, indicating the chip will start to break when 116 gram of force is applied.
In order to test the phase transition, an experiment was conducted on potato chips with two different conditions. Potato chips A and B were placed in the room temperature for 1 day, but potato chips A was additionally put under 4 degrees Celsius for another 1 day. In our result, moisture content of potato chips A is 4.3%, while for potato chips B is 4.6%, which is slightly higher than the potato chips A. This is because water removed from potato chips A and formed ice in freezing condition, thereby reducing the moisture content of potato chips A. This action will recover the crispy texture from rubbery. When we compare the texture of these two potato chips, the potato chips A perform a more rubbery texture than a potato chips B. This is because potato chips A undergoes glass transition when we take it out from the freezer to room temperature. Temperature of potato chips pass through the glass transition temperature and stop at room temperature before the melting point, so it changed state from glassy to rubbery. Potato chips B was not too rubbery as potato chips B as it absorbed moisture from the surroundings slowly. Based on our texture analysis result of potato chips under normal conditions, rubbery state of the potato chips will affect chewiness and gumminess of potato chips. Amount of force required to deform these potato chips are higher than the hardness of normal potato chips, which is 683 gram. The adhesive force needed to separate the potato chips by mouth biting is greater than 2 gram. This indicates more energy required when eating rubbery potato chips. Fracturability of rubbery potato chips also will be higher than 160 grams, which means the chips will start to break when a force higher than 160 grams is applied. Phase transition are changes in the physical state of material including food components, which has significant effects on food physical properties. Most phase transition undergoes phase changes in their main food components such as carbohydrates, lipid, protein, and water. Phase transition change in the physical state due to a change in temperature and a change in pressure.
In the aspect of food microbiology, food spoilage, or more specifically microbial spoilage, has an extremely high chances to happen. So what we can do is to prevent it from happening by using different type of preservation method, including using the nitrogen gas to reduce the oxygen content in the packaging during the packaging time, or we can also use some technology to help us prevent the food to get contaminated easily by
In the aspect of food
microorganisms.
physics, the water activity of the food product is 0.398. Under this water activity, the growth of microorganisms and the biochemistry reaction are inhibited. It also shows a moisture content of 4.6%. As of color analysis, potato chips added with fine powder provide a brighter color as its liner is greater. Its color more towards to reddish and yellowish. In terms of texture analysis, the potato chips are crispy, having coarse surface and gritty texture when added with coarse orange peel powder. Potato chips undergoes phase transition when they are placed under room temperature for 1 day. However, potato chips with freezing have a crispier texture than one without freezing, as freezing can help to restore its original texture.